Okay, this video tutorial looks at the mathematical strand of probability, and more specifically we're going to focus our understanding on probabilities from table data and probabilities from Venn diagrams. So when we're looking at probability from table data, we're looking at essentially or usually a frequency chart, okay, such as the one below. This one represents individuals' favourite clothing. And we can use this table to help us determine probabilities of this certain population that we're looking at. So the frequency side of our table represents the amount of times the data was collected, okay, and the total down the bottom, obviously, we've surveyed 150 people here. And the relative frequency is given by the frequency divided by the total of the frequency. So for example, 0.207 was actually 31 divided by 150, because 31 people chose Nike or Nike, and we divided that by the total number of people, which we've said already was 150, and that gives us our relative frequency. Okay, so relative frequency, remember, is our frequency divided by the total number. Now, your total of relative frequency will always be 1. If it's 0.01, that's fine, because the 0.01 we can just ignore. It's too small a value. So you should always have a value of 1 as your relative total for your relative frequency. So let's have a look at an example where we're looking at probabilities from a table data. So it says a group of teenagers were surveyed regarding their favourite flavoured ice cream. The data is shown in the table below. Now, the first thing we need to do is work out how many students were actually surveyed. So in order to do that, we need to add up all of the numbers in the frequency column. So we've got 11 plus 7 plus 14 plus 18, and that gives us a total of 50 teenagers. All right, so in order to get the relative frequency now, we need to divide each individual value for the flavoured ice creams by the total number in the frequency column. So in other words, our relative frequency for chocolate is going to be 11 divided by 50. So 11 divided by 50 is going to give us 0.22. Now our vanilla would be 7 divided by 50, which is going to be 0.14. Our strawberry divided by 50 is 0.28. And our other divided by 50 is 0.36. Now if I add all of those together, that should give me a total of 1.0. And that's how we work out our relative frequency. Okay, so remember from our previous slide, relative frequency is given by the individual frequency divided by the total frequency. Now question B says, estimate the probability that the next teenager likes chocolate ice cream. Well, the probability would be 0.22, or 22%. Or if you wanted to, you could say 11 out of 50 chance. Now sometimes we're going to be asked to work out probabilities from two-way tables. And now two-way tables basically have two bits of information on them in which people are being surveyed for. So in this particular example, it says a group of 60 students were asked if they played tennis or football. Now some of the students played both, some only played one sport, and some didn't play any. All right. So the first thing we need to do is complete the table. Now, in order to fill out these blank columns, all right, we need to just add the numbers. So we're going to add the numbers going down. 15 add 13 gives me 28. 12 add 20 gives me 32. Okay, so I'm adding down, but I can also add across. Oops. If I add across, I get 27. If I add across, I get 33. Now, if I add down or across, hopefully I should get the same answer. 60 on both. Perfect. And that's great because the information told us that 60 students were asked if they played tennis or football. How many students played just football? Well, if we're looking at just football, they played yes for football, but no for tennis. So that would have been 12. Next question says, what is the probability of randomly picking a student who played tennis but not football? Well, if you played tennis here, that's a yes for tennis, but it's a no for football. So randomly would be 13 out of 60 as our probability of randomly choosing picking a student who played tennis but not football. Okay, so now we're going to look at probabilities from Venn diagrams. Now, a Venn diagram is just another way of putting multiple bits of data on the one visual. All right. So here's a question that says the Venn diagram shows types of group workouts taken by members in a gym. A represents aerobics and Y represents yoga. Now, how many members were surveyed? Okay, so every little dot on this Venn diagram represents a person who was surveyed. So we've got 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So there were 35 members surveyed. Let's see if I can write that a little bit neater. Because there are 35 dots. And it says if a surveyed member is chosen at random, what is the probability that a member goes to both aerobics and yoga? Now that section will be the section that crosses over, okay, right in the middle here. So these people in here, they go to both yoga and aerobics. All right, so how many dots are there? There's 1, 2, 3, 4, 5, 6, 7. So that gives me 7 out of 35 members, which can be broken down to 1/5. Okay, so 1 out of 5 of our members do both yoga and aerobics. Now you can leave it as 1/5, or obviously we can change it to 0.2 or 20%. Okay, so here are some practice questions I'd like you to have a go at. Please feel free to pause the video, have a go at them. When you think you've got the correct answers, continue the video, and we'll see how you went. Okay, so let's see how you went. In our first bit, we've got a two-way table. First thing we need to do is fill out the table. All right, so obviously we're going to start adding down and adding across. And that's going to give us a total of 50. And the first question said, a person who catches a train. Now the people who catch the train, there's 13 people that catch a train, so the probability is 13 out of 50, or 0.26, or 26%. And the second one says a female who drives a car. Now we need to look at the cars. There's only 9 females that drive a car, so that's going to be 9 out of 50. See if I can write that a little bit neater. And that's going to be 0.18 or 18%, would all be fine. Now, next question, the Venn diagram talks about football injuries, where K represents an injury to the knee and A represents an injury to the ankle. Talk about how many footballers are there in the team. We need to count all the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, 17, 18, 19, 20, 21. So there are 21 players on the team. If a footballer from the team is selected at random, find the probability of the footballer has had an injured knee. Well, that's everybody inside the K circle, including the people in the middle. So it's going to be 2, 4, 6, 8, 10, 12, 13 out of 21. In fact, I'll write my answers over here. I is 13 out of 21. Double I says an injured ankle, but not an injured knee. That would be people who in the ankle section, but not counting the overlap. So that would be 5 out of 21. 1, 2, 3. Either injury, so they've had either a knee or an ankle, but not both. So that would be everyone inside the K and the A, but not in the overlap. So that's 5 6, 7, 8, 9, 10, 11, 12, 13. Hang on, start again. 5, 7, 8, 9, 10, 11, 12, 13, 14. So that's 14 out of 21. Oops, 21. And we can cancel that down to 2/3. And the last one, both injuries. So that's all the people on the inside of the overlap, which is 4 out of 21.